Today we are going to learn about control structure. We're going to ask ourselves, what is a control structure? And then we're going to answer questions on that. Now, in programming, there are three main types of structure. There is the sequential structure, there is the selection structure, and there's the repetition structure. So far, most of the questions we've done have dealt with the sequential structure. What do I mean? For example, we have a question like this. Given A is 5, B is, let's say, 7, and C is 10, display the average of numbers, display the product of B and C, and then display the difference between B and C. Now, the average of the numbers, and in this case, they said all the numbers, is given by summing up all the numbers and dividing by the total numbers we have. So in this case, A plus B plus C all would be summed up, and after you sum them up, you would find the average as the sum of the numbers divided by the total numbers you have. In this case, is 3. For the second question, it says the product of B and C. Our math tells us that if we say product, then it means we should multiply. So it means that the product is equal to B times C. Now for the difference, our math also tells us that if we want the difference between two numbers, then we must subtract. So it means it's B minus C. And this here are the solutions for all of them. So once we are given this, we must first of all create variables for these three numbers. So here, I'll go to my code side. I've already opened up div C++. If you want to open up div C++, you go to File, you go to New, you go to Project, you choose Console Project, type your name here, and then just save the project in a particular folder on your computer. When you're done, you see the window I have here. So the first thing I'll do is I'll create variables for what they said we should, the given numbers were given. So here I have int A is 5, B is 7, C is what? 10. Why did I choose int? I don't see any decimals here. So of course, when they are integers, I can choose int for that. The next thing in which I have to do is create the variables that will hold the displays I'll be having. In this case, I'll be having 1, 2, 3 displays, and then I'll have a fourth display to hold the sum of the numbers in which I am using. So here I'll have int sum, comma, product, comma, and finally diff for difference. And then I'll have double average to hold the average in which I'll be performing. Now all of these ones, I'm going to initialize them and give them initial values of 0 so that the variables are not kept empty. Very good. So now that I have all the variables I want, I can now do the computations I have to do. So one of them is sum is equal to A plus B plus C. That is, I want to find the average of the three numbers. And then the average would be equal to the sum of the numbers divided by the total numbers, which is 3. The next one is for me to find the product. So product is equal to B times C. And finally, I have to find the difference. So difference is equal to B minus C. With that, all I have to do now is I have to display them to the user. So Cout, the average is AVE, and now Cout, the product is product, and now Cout, the difference is different, and now. Okay, so the difference we used this. Sorry. So now I can compile. I have no errors. So you can see that I have my average is 7. So this divided by 3, I should have 7. And then here, 7 times 10 will give me 70. And I have 7 minus 10, which will give me negative 3. So it is doing what the program asked me to do. Now, in this question, you see that we moved from line 6 to line 7 to line 8 to line 9 to line 10 to line 11 to line 12 to line 14, 15, 16, then we stopped. There was no decision making in the process we're doing. So that is the sequential structure. Now we are moving on to the next structure, which is the selective structure, or the branching, or the choice making. Here, we would have some statements that would be executed. So an action to be performed, something you will do. Now, you would only do the thing if a certain condition is met. Now, how will I know if that condition is met? It has to be either true or false, which means the questions we ask the computer, that is the condition, has to be in a form whereby we can either answer true or false. It has to be framed in a way whereby true or false is the only answer we can get. Now, remember that we will only do the thing if the condition is met, and the condition is met so that it is true. When it is false, it means we will not do the thing we want to do. We will not do the thing we want to do. Now, in order to achieve that, so you can see, before we go there, you can see in the diagram, we have an expression here, that is the condition, and if it is true, we will do something. If it is false, we will do something. We may not do it, we may do another thing. If it is true, then we will do what we are expected to do. Now, one thing we need to know that because the condition, we must ask it in a way that would either be true or false. It means we must use a relational operator to do comparisons between two numbers. Now remember that before I can do a comparison, I must have two things. So you can see that I require two operands. And the evaluation of them must always be either true or false otherwise. The way you frame it, you must have only two answers in which you can give somebody. So for example, is 8 smaller than the character 5? This is something in which you are trying to compare an integer to a character. So this is a no-go. You can't compare a dog to a cow. So it's a no-go. It must be framed in such a way that after it is evaluated and you're comparing two things of the same kind, you might get an answer which is true or false. Now to do this, comparison, we need some operators, and they are called the relational operators. So we have the equal to sign, we have the not equal to sign, we have the less than, we have the less than or equal to, we have the greater than, and we have the greater than or equal to. Remember, the single equal to sign stands for an assignment and is therefore an assignment operator. In this case, the two equal to signs here give you the mathematical equal to the I am the same as the other entity. That kind of equal to, we are the same. That is what you see in this section here. So with that in mind, let's look at some examples. So over here, I have another question for us to try our hands on. So question 2. Write a program to accept two numbers from a user. Display the greater number. Now, looking at this problem here, this question we have here, what is the problem in which we can identify of which the user wants us to do? He wants us to find or develop a program to find the bigger number. Okay, simple enough. So we are supposed to write a program to find the bigger number. Now, in a scenario like this, what do I need to find the bigger number? So I need two numbers. I need value 1 for my first number. I need value 2 for my second number. Okay, all is well. Now, at the end of the day, what do I tell the user? What is going to be my output variable? I'm either going to tell the user that value 1 is bigger, or value 2 is bigger. And in this case, I don't have any variable to store the information in. Here, I just have to tell the user which one is bigger. So there is no need for me to keep this in a variable. I'm just telling the user as an output. After I determine which one is bigger, then I just have to tell the user, oh, value 1 is bigger or value 2 is bigger. Okay. So now I know what I want to do. I know what I need, and then I know what I'm going to have to display at the end of the day. Now I just have to write my program. So I'll come back to my div C++. I would quickly erase this so that I can have a new place to type my work, and I can begin. Remember, for every project, you need to include IOStream and then add the using namespace std. So my input variables, what are they? I need two numbers. So the user will enter any two numbers are random. So I'll use it for value 1 and then value 2. Now the second one is I must ask the user for the two numbers. Now the asking process of the user is in twofold. First of all, I must ask him, then I must receive. What do I mean? Let's say I write C in value 1. and I say C in value 2, and I compile this, and it runs. There's nothing wrong with this program. So when a user comes here, what is he supposed to do? There are no instructions to what the user is supposed to do. So since I wrote the program, I know I have to enter 12 here and press another 12 here. But since you didn't write the program and you are the user, when you come, you see nothing here. So what are you supposed to do? Hence, before you accept the number from the screen entry, you must ask the user, you must direct the user as to what the user is supposed to do. So please enter number 1. And in the section here, so I'm going to go, please enter number 2. Now, when I compile this and I run, you can see that the first step, that is point 10, begins, whereby the user can now enter his first number and then his second number. The user knows what to do. At this stage in line 13, I have the 2 numbers. So now I must determine from the analysis I did, which one is bigger? Which of the numbers is bigger? The moment you are writing a program which deals with, I must compare, I must make a decision, I must make a choice, then that means that the conditional statement has to be made. So now, how do we write a conditional statement? How is a conditional statement supposed to be written? So to write a conditional statement, you need the keyword if. Then you have your condition. Then you start with the body of the condition. Now it is in this body that any action you want to do, if this condition here is true, will be performed. So everything here will only be performed if this condition here is satisfied, and it is satisfied to true. If it is not true and it is false, then there must be an alternative. So you have your else statement here, and you have your block 2. So we have one block here for if the condition is satisfied. We have another block here if the condition is not satisfied. So if here is false, then it means here will be performed. What do I mean? If, let's say, I have 2 numbers here, 2 and then 5. Is 2 smaller than 5? In this case, it said bigger. So let me use the greater than 5. Sorry. Is 2 bigger than 5? It is not bigger than 5. Therefore, the else statement would be evaluated for us to say that value 2 is bigger. If I have 2 values again, let's say 5 and then 7. Is 7 bigger? Oh, sorry. Let me put 7 here rather, and let me put 5 here. Is 7 bigger than 5? It is. Hence, the statement here would be evaluated. Hence, we have value 1 is the bigger number. Okay, let's take it again. Let's say I have 17 here and I have 55 here. Is 17 bigger than 55? It is not. So here would change to what? No. Hence, the statement else would be run. Okay, let's take it another way. Let's say I have 171 here. Is 171 greater than 50? It is. Therefore, this condition here is what? True. Therefore, the if statement block here would be executed. But in this case, we have value, let's say, finally, the final trial thing, whereby we have 55 and 55. So with 55, is it bigger than 55? They are the same. Hence, it is not bigger than it. Hence, value 1 is the biggest. So in this conditional statement, again, we have value 1 being here, and we have value 2 being here. It really doesn't matter. If value 2 is equal to 171, and value 1 is equal to 171, and value 2 is equal to 55. Is 171 bigger than 55? It is. So it means this statement here is going to be run. So our condition is take whatever the person enters in the first value, compare it to whatever the person enters in the second value. If it is bigger than it, then evaluate the first expression. If it is not, then evaluate the second expression. And with that, I can determine if a number is either bigger or smaller. So now I can bring it to my code. So I have my true condition block here, I have my false condition block here, and then I have this expression showing to the user. But of course, in C++, we don't just write an expression like this if we want to save it to the user. We use the word cout, and then we put it inside a double quote to show that it is a string. I'll bring NL so that my expression will evaluate to the bottom. So we run. So two numbers. So I have 90 and I have 190. That means what should show me here is what? 190. So value 2 is bigger, which is correct. But this program is not, it's not talking to me. It's not giving me the feedback that there's intelligence in it. So I want to give it that feeling of intelligence. So this value 1 goes away. This value 2 goes away. And then I can bring an expression in front here as in value 2. And I can bring another expression in front here as in value 1. So now this is what I have. So I compile again. And then I enter 55 here. I enter 35 here. And I press. And 55 is bigger. So now it's more intuitive. The person sees, okay, the first number I entered really is bigger. So the first portion of the if statement deals with us learning about the single if. So if an expression is true, then what do we do? Here, if it is false, we do something. If it is true, we do something. Of course, in life, sometimes you have to make multiple decisions, not just two. If it is this, I will do this. If it is that, I will do that. If it is another thing, I may do that other thing. So you may have 10 conditions you have to evaluate and pick from 10 different pathways. That means the next time we'll do the if else if statement, whereby you're not dealing with just two um, conditions, but you're dealing with multiple conditions to be satisfied. I hope this is uh, educative, and I please practice with the questions in which I have been giving you. Watch this over and over again, and if there's anything you don't understand, you can give me a call on my phone. Thank you very much, and enjoy your day.